You're looking at a oscilloscope, and this is the output of my signal generator that I'm using to simulate the cam and crank sensors on the Hayabusa. The top waveform here is the cam sensor, and the bottom signal here is the crankshaft. And what you can see here is right now I just have random data programmed into this signal generator. The signal generator is basically an ARB, and I've got a certain amount of memory that I'm using to play back continuously. So I just program up that memory with the waveforms that I want and start dumping them out. What you see is, again, this top one being the index pulse for the camshaft, and the bottom waveforms here being the tone wheel for the crank. And you'll have one camshaft index for 2 rotations of the crankshaft there. This is the 24-1 waveforms, and again here we can see the cam and the crank sensor, and you can just kind of see the -1 pulse in here. If I start to zoom in, you can see our one missing pulse, and missing pulse here. So if we zoom in a little bit further here, these 2 waveforms are not locked together, so in the ARB I can control those 2 signals independently. So if I want to change the phase relationship between the 2 of them, I can easily move that around. So now you can see that the cam pulse is located quite a ways off from where it would normally be. Another thing I can do with this signal generator is I can FM modulate this camshaft timing. The piston will accelerate as it goes through the combustion cycle, and it's going to de-accelerate or slow down, I guess, as it goes through the compression cycle. So if I want to simulate that, here you can see that in time I have like these pulses here that are a little wider, and it gets a little narrower, and I can make this waveform pretty much whatever I want. So this will repeat that cycle for every combustion stroke, and this is all done in hardware. Another thing I can do is change the polarity of the 2 waveforms. So if I want to change the crankshaft sensor, its polarity, or the cam sensor, this is another waveform that I can output. This waveform is used internally of the design and is used to synchronize all the digital logic. This pulse is actually the location of TDC1. The slew rate of this generator is also programmable, so I can make it slew very quickly, or I can have it slew very slowly. So in this case, I've just turned up the speed quite a bit, and you can see that the hardware is slowly speeding this thing up. And again, this is a hardware feature. It has nothing to do with my software. We can slow this down to pretty much whatever I want. You can also speed it up basically as fast as what the hardware can spit out data to the registers.